time to stream. Late one today because it is. Oh, I meant to do this as a cool thing when we start up. Welcome back to the project. Sorry about the late stream today. It is what it is. As long as I get to it every day, that's all that matters to me. So, as you can see over here, that is coming straight off of this, you can kind of see it, an actual NES over here. And that is the code that I wrote prior to kind of the current cycle of things. The current cycle, I am working on this keyboard, this gangle of shit, and it all plugging into the NES to pair with this. This is, I basically wrote a text printing library that roughly acts like a more or less serial terminal sort of thing, where it will always just print the next character in the next location. Next location, that's what you get, and it supports new lines and carriage returns, and that's it. So the goal here now is to, last couple of sessions, we got the keyboard hardware tentatively working. It looks like it's working hardware-wise the way that I expected it to. And you can see the NES is actually currently powering it. If I power off the NES, it's off. Now it's off. So like we're plugged in, we're good to go. So it's software time now. The annoying thing is, because there is no, emulation of this thing that I just built per my own made up specs in any NES emulators. If I had time, I would find an open source emulator and just bash in support for this keyboard so that I could work on it in the emulator, but I have no time. So instead, we're just going to try and get the code to work and then jam it onto, if you haven't seen it, my little bastardized, this is a Super Mario Brothers 3 cart with the Tower of Power on it, which is just adapting an EEPROM into the mask-ROM socket so that I can write my own code to it without actually going to the trouble of buying a nice proper flash card or anything. Because if you're just joining this channel, it's about me making bad choices and hacking things poorly. So I guess let's just hop straight into the code today then. That is fun. Oh, I'd be curious to know why that happened. That was oh, because I yanked the card out while it was on. Boy, what a dingus I am. Anyway, so yes, back here. I should have the code up over somewhere hiding here. And so right now, I guess let's clean this up a little bit because we don't need this anymore. That was a test string to prove when I was developing the character printing routines that I could in fact print all characters. Most of the punctuation is absolute garbage because I don't have control over the character ROM. So I have chosen what Super Mario Brothers 3, what the Super Mario Brothers 3 tile set has deigned to give me. And then this is that code that's printing right there, where it says to the left at the top, and then prints look around you. So we've got a bunch of initialization code and whatnot, kind of boilerplate stuff that if you want to know more about it, look back at previous sessions. We set the background and foreground palette stuff, which is going to remain static throughout this whole thing because we kind of want it black and white. I might make it amber. You think I can make it amber on black? That would be fun. Maybe at some point, but at the moment, I just want to get this to work. So my thought for today is, I think the easiest way to debug this thing, I'll go over quickly for those who just hopped in, roughly how keyboard stuff works. Let us see. Let us go back to the old Googles. Hey, Trey. Trey Dempsey has popped in to say hi. A channel regular. yeah, let me pull up the TI-99 4A keyboard matrix image again that I have been using, which is what this keyboard is, because other people have screwed with it. So there's a nice keyboard matrix here. And basically what happens is with the NES, sorry, I have to re-explain this over and over and over again. Bear with. We scan through, basically there's a chip that in turn will put voltage on one of these column lines at a time, and then we will read all of these rows. That's basically how keyboard matrix scanning works. For the way that this hardware works in particular, we read all of the rows into a parallel in, serial out shift register, which is the normal way that an NES controller works. Normally you'd have like 8 buttons hooked up to one of those, and there is a latch output and a clock output, excuse me, on the NES controller port, and latch latches in the values of all the buttons, and then clock shifts them out one at a time over the data line, and then you read that individual one. So the way that this basically works is that every time we latch, it selects the next matrix line, and then we can, clock in. That also latches in the values that were on the rows, and then we clock those in and read them just like they were controller buttons, and then we latch again, it moves to the next thing, resets the shift register, latches everything in, and then we can read them again. So now we just have to write software to do that. And I'm thinking the way that I'm going to debug things is I think I'm just going to print the keyboard matrix on the screen. I think that'll be relatively straightforward-ish. For easiest starters, because my idea here is just to test that I can read all of the keys and they all work. Ultimately, what I'd like to do is literally print like an 8x6, grid of characters on the screen. Probably just like print a 1 character if the button's down and a 0 character if not, which I should be able to do relatively easily with my character printing code. I'd just print a line and then a new line, do that 6 times, and then I'd have to manually reset my cursor back to the beginning of everything and redraw, but that's relatively easy. But I don't know if I'll get there tonight, seeing as I do want to go to bed at some point. So let's start with seeing if I can just... let's just try and latch in... Yeah, I'm just going to make a loop that will apply the latch, do a clock, which you also need to do a clock on the first latch because these are synchronous gals that I am using. So you can't have an asynchronous latch and clock signal. Everything has to happen on the clock. So that's a fun thing. Anyway, just write a loop that hits the latch, does a clock, clocks 6 times, reads that into a register or something, and then, I don't really need to. For each one, if the pin was high or low, I will just print a 1 or 0, and then print a new line and do it again. So it'll be like a kind of a version of this matrixy thing, except that's going to keep constantly printing. So yeah, clock out 1 column, as Trade MC says, is where we're going to start. So let me just frickin' do that then. So we have a fair bit of, we're still in the setup stuff here, but finally, this is our big screen in it. Everything is ready, and we fill up the screen with some blank tiles, which is what blacks out the whole background. We initialize the position of the cursor to upper left-hand side, and finally, somewhere in here, we turn the NES's GPU on. We do some MMC3 stuff, which is the mapper which controls how memory is mapped on the cartridge, which can do many funky things. And finally, yes, this loads the address of our hello string, which is that to the left text, stores it in a 0-page address. There's probably a better way to do this, but this is what we're doing for now, and then calls this print string subroutine, which just prints that string. But we don't need to, well, you know what? I'm going to keep the to the left text. It's classic. It deserves to be there. And then we basically print a new line. Can't remember which one is which ever, but a new line and a form feed, or no, a carriage return and a form feed. A new line and a, not form feed, yes, form feed. New line. Can't remember if form feed is the technical word for feeding the whole form through the thing, because that is also an ASCII character, is feed the entire sheet for, you know, assuming you were working with a printer or a teletype. Anyway, moving on. And then all this does is FF times has this loop that prints the look around you text over and over again. And we don't care about that. So what we're going to do is, I guess, rip out everything from the beginning of print loop to here, which is just a halt loop. But it's a very useful halt loop for us because this is actually really old code that I wrote way, 20 work sessions ago, wildly enough. Oh, I didn't even change the title of this video. Whoops, I will have to do that when I'm done. Sorry. Oh, actually, I think I can do that right now. Let us see. Usually I do this right before I start streaming, but, oops. Let's call this keyboard driver, part 1. And of course, we need the rundown. I have no idea if anybody actually even reads this, but... So, what did we do yesterday? Yesterday, we finished the proof of concept of the keyboard to NES glue hardware. That's pretty much it. That's pretty straightforward. And then today, the goal is proof of concept reading keyboard rows using the actual NES and debugging by printing key states using the character printing library. Okay, I hope you enjoyed watching me type that. Episode 21. How wild is that? I guess when you do one every day, they start to pile up. Okay, back to the code, right? Yes, let's do that. So this loop from way back in the day is basically, let's see. Oh, bit 2002, and this branch thingy is waiting for v blank. For no good reason. I'm not really sure why I'm doing that there. But ignoring that, this is, I believe, reading controller 2's data input pin, and then anding it just to get the single data pin value, which is probably unnecessary, and then writing it to controller 2's maybe it's, no, this is the 4016 is the latch output, I think. This is something we're going to need to know, so let's NES dev controller. Okay, so yes, input is, I guess this is input to the controller. Seems like a backwards way to write it to me, but so writing to this register, yeah, basically sets the latch pin. So I don't know what this code really does for us beyond the fact that it has those two registers in there. But this is where we will start. So I guess really what I want to do is maybe, you know what, actually? Maybe I'm going to keep the v-blank thing there because I don't know why it was there. I don't think it matters, but before that, actually, I'm literally just going to write a bit of code that will set the latch pin high, which puts us in latch the current row mode, and hit the clock for controller 1 once, and that way I should be able to keep hitting the reset button on the NES, and if I press keys on the keyboard, we should see LEDs change, and that means that things are working more or less, things are hooked up right hardware-wise. So, that was, let's load into A the literal value of 0, 1, because the only value in this register that matters is the low bit. So 0, 1, and then store it to 4016, was it? 4016. So that will set the latch pin high, and then we read from 4016, let's see, I think. Controller 1 is read through 4016, and I think that's what I'm plugged into. Yes, I am. So, let's do that. I should just be able to do a read to 4016, and that should clock it once, and that's it. Theoretically. I'm trying to decide if I just want to put this whole thing in a loop with a like time delay loop in there, just so that I can kind of keep it free running and keep an eye on it. I might do that. I might, but I don't know how. I'll just put a time delay loop in it, and we'll see if it's too fast or too slow. And yeah. So the core of this is we set the latch high, and then literally we can just sit here and loop. Oh, you know what we can do is I can do it right in echo loop, and we can. This code, like I said, it waits for VBlank. It looks pretty esoteric, but that's what it's doing. It's reading our register on the GPU, and if the bit that says we're currently in VBlank isn't set, it jumps back to here. So that'll give us pretty reliable, 1/60th of a second wait, or 1/30th. I'm not sure. 1/60th. I don't know. Something like that. So if I just wait like 60 cycles, then that should be a 1 second pause. Sure. Seems reasonable to me. So what we want to do is actually, before this, what I will do is load X let's load X a literal 60, and then we will DEX after we have waited for VBlank, and we will branch if it was 0, or no, let's branch if it was not 0, right to, like, I guess just an echo loop, just start the loop over again. But let's see, clear carry, branch carry clear, echo loop, and right before that, if the if X did get counted all the way down, then we will load A from 4016, which should give us 1 clock on here and switch to the next matrix line. So we should see a new matrix line on these LEDs every second if this works right, or 2 seconds if it's at 30. I'm not sure. And after we've done that, we should load 60 back into X again, and that's pretty much that. I think that is fine. And you know what we can do for sanity checking, because you should always make sure you're sane, is let's just print a character every time this step happens. And that way it will just be visible, and I can run this really quick in the emulator just to make sure it, actually prints a character every second. And let's make that character, I don't know, can I just do this? I'm pretty sure I can just do this. What character do I want to print? I don't know. I'm just going to do an X, because whatever. And there you go. That should pretty much do it. Wait. This gets back into that thing where it print char screws up all of my registers. But the only register I care about is X, so let's just load 60 back into X after we do that. Then we should be fine. Yes, that's the only register I care about. Seems believable to me. Let's build that. And let's load it into FCEUX to make sure it doesn't like do something insane. Cool. That seems like a reasonable rate. That's exactly what I want to see. And theoretically, it's also reading in from the controller too, but we're not really going to see anything from there. So let's just go ahead then and go to the, sure, let's go over here. 20 working episodes, and I still have not figured out what hotkeys are which angle. Yeah, so let's make sure this is off, and then we will pull the Tower of Power. We have not done this in a while, so this is momentous. And rip this poor EEPROM out of the socket. And rip the socket out of the other socket. Just wait with bated breath. People who watch will remember the, like, the second to last episode before my vacation. I just, destroyed this thing and had to resolder the whole adapter. So, let's not do that again. Ooh, air conditioning is off. Now it's spooky quiet. Alright, put that in Yarn Programmer. Let's see if I get this on the first try. Ha. And now we have to switch our freaking chip again because we were working with the gals before. And I don't even remember what this is called anymore. This is a 29EE010. 29EE010. That seems reasonable. I think these are all copies of more or less the same thing. And load. It's been a while since we've done this. Basic.bin is the binary version of our image. And we need to do an offset of 10,000 hex. And okay. That is theoretically loaded. Let me make sure I did that right because it's been a minute. There is our boot vector, so that looks fine. Don't check the ID because that never works for some reason. And give it the old program. Julio Cesar Garcia says, do you make a keyboard for NES? And the answer is yes. It will only work with my own software here because it's, you know, it's not like made to work with any games in particular, but see, Julio, see. That programmed? That programmed. Cool. Let's go over here for a second and pull this out of the programmer. And you can have fun watching me plug this EEPROM back into this horrible, macabre assemblage. Okay. I think it'll work first try. Oh, now I have to also do another view where I move, because we're going to want to see the hardware and the frickin' output of the NES at the same time. Oh well, I'll tell you it first if it's working. No. Let's do this. Let's just go ahead and do this. Let's keep on editing this view, which already has like a window off screen that I can't get back again. Yep, it's somewhere on the OBS display, and oh, here it is. There we are. So that's hiding over here. Let's just go ahead and add the game capture to add existing. I think, which one is this called? RCA? What did I name it? I think that's it. Sure. Okay, there we go. De nada, Julio. That's the full extent of my Spanish. I'm just turning this on, right? Is it ready? Okay. So, that looks like it was doing a thing. And eventually we should hopefully get one that lights up because it's on the 0th row. But I don't know that I am seeing that, which is a little annoying. Nope, it's not just the camera. I do not see that. Haha. Let me grab an LED and I don't know what I think I'm going to be seeing here. I guess I can look at the actual matrix lines here. Julio, you can download nothing anywhere right now because this exists basically in my brain and on this bench right now. I might try and release some, I don't know, schematics and software if you want to play with it. It's pretty one-off though, this one, so that's unfortunately the way it is. Okay, so theoretically, what am I even trying to do here? Which ones are my matrix lines? These are my matrix lines. You can't really see them, but what I'm going to do is I am just going to see. Okay, so hold up. It's moving too fast for me to demo. Did that show up somewhere? Come on. I guess I'll just have to hold one on there and we'll have to wait. But it's working. I just have this plugged into one of the matrix lines so we can see that one of them's going high. There you go. So they're cycling. Dirt Piper says XXXXXXXXX. And that's true. That's true if you really think about it. XXXXXXXXX. So let me just, the thing that I'm really trying to sanity check here is my line 0 line, which is pretty important. In that's how I'm going to be detecting rows or column 0. And it is not doing anything, which is troublesome because, yeah, next to the last one is doing stuff just fine. So I'll have to check to see if that's like unplugged. That's the one right next to it. So is that unplugged or some dumb crap? Let's see. That comes from over here. Guess let me look at it. So that's the other side of the diode that it's going through. So I guess let me check where it's actually coming out of the chip here. I mean, there's nothing but a diode in between the two of them. Let's see, I'm doing that. Yep, next to the last one is fine. But number 7, never appears to happen. What? Why would that be? Okay. I guess I really need to look at my actual, like, count chip, because one of these chips is doing the doing a 3-bit count, and then the other chip is converting that to decoded 1 pin at a time selection. So something has gone weird since yesterday. So I am just going to plug LED into those 3 count outputs and see if they ever go to 7. because they should. They definitely should. Piece of crap. Some of these wires are just worn out from years of me using these otherwise very useful LEDs. Good enough. Well, I definitely just saw a 7. Ooh, this is in there. Only sort of. I can't have the cartridge in and do tweezer work at the same time. It's just one of those curses. Oh my god, come on. Am I cursed today? I just want to put a wire in a freaking hole. That is all I ask. Okay, let's try another LED. 0 for 2. That seems better. Third time is, I guess, always the charm. Okay, watching these count. I don't know if you can see them. No, they are on the other side of the wire, so. Let's see. Is this looking reasonable? That's 7 right there. What? Okay, that looked weird, right? 7. Like, we're never hitting 0. What is going on here? Let's see. Which one is supposed to be my lowest order? Like, what on earth could have happened since yesterday? Okay, yes, so this one is the lowest order bit. This is the second one. This is the third one. So, yeah, it like never goes all the way back to 0. What the hell? It goes back to 1. What did I screw up, you guys? What even is this count? So 7, 1, 2, 3, 5, 6, 7. This was working just fine. This was working just fine yesterday. Oh, this terrible lighting. What? Tell me I have them plugged in like in the wrong order or something. No, it doesn't really look it. It's orange, blue, purple. On this side it is also orange, blue, purple. So I didn't screw up the order. And I mean, they never all turn off, so there's no order in which... Huh. I wonder if it's just my code is slightly wrong and there are startup states in which it does weird things. Yeah. Well, the really weird thing is that I believe the logic for this lowest one was just that it should toggle all the time, and it only seems to toggle part of the time. See, it's like high, high, low, high, high, low, high, high, low, high, high, low, high, high, low. Interesting. I think my logic is just bad for this counter. Yeah, sorry. That was a very boring moment right there. Trey is trying to get me back on track. He says, "Can you explain what's going wrong? Is it the column counting from the gal that's not working?" Yes, apparently the counter gal is just straight up counting wrong all of a sudden. So I'm not sure why, but that's what's up. So I think my logic is probably just wrong there. So let's revisit, let's pull this gal out and let's revisit that logic, because something is not right here. So it starts up, for my own remembrance, when it powers on, it's always, and I mean, power on state is arbitrary, you know, you should never assume that your power on state is going to be anything in particular. But the power on state here was always all 3 bits were on, so it was set to 7 effectively. And then the next clock was giving me 2. So that was all of them off except for the middle one. So let's look at the logic and see if that's what would happen. Still, the weirdest thing is what I was seeing there that I was really scratching my head on. Let's open the right one. Latch count. Already open. Cool. Is that Q0 should always just be, if latch is high, which I wonder if, I would not be surprised if that was backwards from what I thought it was. Because the NES inverts a bunch of weird stuff. Let's actually, shoot, damn it. I shouldn't have just ripped that out. Frick. I'm going to shove it back in really quick. Well, actually, no, I don't need to shove that in. All I want to see is the latch output actually high? Because that would be an important thing to check. I mean, we shouldn't be seeing any counting if the latch isn't high, so surely it's high. But allow me to double check here. And let me make sure that like nothing is touching in a weird way. Doesn't look like it. Everything looks pretty much fine. Yeah, looks pretty good. So which one of these was latch? I believe this one is clock. This one is latch. So I need to put an LED on that one, because clock I'm sure will be too fast for me to actually see. Because the clock only happens every, second here, but the clock pulse is very short. Okay, let us make sure that latch is actually on. Oh, I gotta put the tweezers back. It's the only way to make sure that the cartridge works. It is vital to the whole thing. Okay, power on. Yep, that's unexciting, but latch sure is high. So D3 is an input. And we're back. D3 is an input. Boy, what a night. What a night. So yeah, I don't know what D3 actually hooks to because... well, let's read this. Because from what I understand, I'm not sure... I mean, this documentation is not great. But it says that the D1 and D2 are only available on the Famicom. But regardless, those D inputs are inputs. They're inputs only. There's really only 2 registers for controllers on the NES, and one is the set the latch output, and the other one is read the input bits, which are D0, D1, and D2. But like I said, I don't know why they're labeled on the controller. Maybe you can use them for inputs, I'm not sure. But those would be D1 and D2, and this is D0. And that's it. Those are all the registers you have, as far as I know. Yeah. So that would be nice, but yeah, no. So back to looking at the logic. Sorry, just checking a thing. The clock appears to basically always be high, which tells me that it is, so that's plugged into the clock line, that it is usually high and then flicking low for a second, which should be fine. I don't think my hardware has a problem with that, but it's something to be aware of, I guess. Anyway, back to looking at my logic and seeing if there's a reason. Ooh, come on, go to the right screen. There we go. Yes, the logic for that gal. So Q0 is just if the latch is high, then every time the clock happens, its next value should be... you know, maybe it does matter, because I believe this gal does stuff on the rising edge of the clock signal, and I don't know. It just I can't think well enough right now to like clearly see if that would be an issue with the actual clock signal being inverted. But let's just check. Because I'm wondering if maybe it's just because of the inverted clock signal, it's actually toggling, you know, effectively toggling twice too fast for me to see, and actually everything is working fine. But the nice thing is I should have a bunch of extra free pins on this thing, so I can just make an inversion pin, and that's all I need to do. So if we just make pin 3 is yeah, this should be fine, right? So basically what I'll do is I'll take the clock signal, I'll feed it into pin 3 of this gal, and then I will take it out of, I'll just make pin 16 the inverted value of pin 3. Let's call this NES clock. And let's call pin 16, I don't know, end clock. And then literally just, let's make this on a separate line so that I see a separation between my registered stuff and my combinatorial stuff, of which this inversion is just going to be combinatorial. And all we're going to do is say invert clock is going to equal not NES clock, the end. Nope, I am still not in Vim. Yeah, so what I'm going to do is I'm just going to take the clock, and it's the clock from the NES, and instead of feeding it straight into the chip, I'm going to pass it into pin 3 first, and then take pin 16 and hook it back up to pin 1, basically, is the magic that's at play here. So let me save this and compile it, which should hopefully go fine. Yeah, no errors. Very good. Thank you. And let us change my chip again. Let's see. It is an AT16V8B. And load the JED file, which is, that was latch count, right? Yes, latch count.jed. And make sure this guy is actually in the socket. Programmer up. And attempt to jam it back into the socket. Which is always fun when you have this many gangly wires going on. Wish me luck. This is why God made tweezers. God made tweezers, not man. Many people don't know this. It is in the Bible. Okay, and with surgical precision, yes, surgical precision. I'm glad that my camera setup is not good enough that you guys can actually see what's going on here, because it's sad. There we go, it's in. That seemed lined up right. Okay, so next step is to rewire some stuff. So this wire is the clock that goes to all of the clock inputs of the gals. And what I'm gonna do is reattach that to, oh God, for a second I thought I reprogrammed the wrong chip. I was terrified. No, I did the right one. Whew. Okay, so this will be coming out of pin 16 of that gal, right? 16 is an invert clock, yep. And then, so now that inverted clock signal will be driving everybody's clocks, and now I just need to, I guess I can just take this now and feed it directly into pin 3, which should invert that clock. And maybe that will make things look better, because it is my suspicion that things are working fine, but it is doing weird things because of the inverted clock. Not weird things, it's just, you know, it's kind of effectively double clocking, and I'm not seeing one of the states as they happen. So, no, this is my general purpose thing now. Okay. I think it's working. Yes, it is. Okay, so back to the bad LEDs issue. But let's see. Nope, this LED is always on now for some reason. What is your problem? Brother. Yep, this the zero LED is just always on now. When it's plugged in properly. Come on, man, just work with me. Wait. No. I keep hoping I see things that are incorrect, but then I don't see things that are incorrect. Which is a bummer. That's a bummer, man. Let me just make sure I wire this in the same way. So this should be the inverted clock signal, which is, you know, now the correct clock signal. And yeah, that's going the expected places. And if I just really quickly check on, what do I even want to check on? I guess if I look at the inverted clock line, it should be effectively always off, as previously it was visibly always on. Not that it was actually always on, it's just the clock is so fast you can't see it. And yeah, that seems like the story. It looks off to me. Wait. Something is spurious. Yeah, it's really annoying that you guys can't see this, and I'm afraid to touch anything. The counting now looks perfectly fine. Trade Empty said, you know, F breadboards, basically. Apparently, yes. They seem fine now, which is concerning. But yeah. You really can't see them, but they're counting fine now. So that's very annoying. Sure. Well, anyway, I wasn't looking at this guy. Do we frickin' see our row 0 LED lighting up now at any point? Still no. That's the annoying thing, is that when it's at 0, it should be clocking a bit into this thing. Oh, nothing can just be easy. Wait, no, it's counting weird again. What the hell is going on? I might have to just call this one a write-off. This is so annoying. I think this is my comeuppance for all of the success that I was having the other day. Well, just up this week so far. Because now it's just doing nonsense. What are you doing? I should have faced these LEDs forward. Yeah, they're just back to counting bizarrely. And it's just the weird thing, the weird frickin' thing is that it's mainly the 0 bit is totally inconsistent. See, it's off, on, off. Just frickin' all over the place. And the logic for that is ludicrously simple. It's literally just, if the latch line is high, then it just inverts itself on every clock. That's it. Is there something I don't understand about the NES where, like, the latch line gets overridden by something? But even still, if the latch line went low and a clock happened, it should just not count at all. So what the hell is going on? Is it just the fact that this is a breadboard and God is mocking me for trying to use a breadboard? Is that what is going on? I legitimately don't know, and I'm at kind of a loss. Because it's just not counting right. Out of the blue. And sometimes. Which speaks to me of, it's probably the breadboard doing weird things. But I can't prove it. And that is frustrating. I just don't have any thoughts right now. Oh. Do I cut it off? It's 10:13. And I don't think anybody wants to watch me, you know, bash my head into the table. So maybe I will just sleep on this. That's a real freaking bummer, you guys. I guess I got some code written this time. So that's cool. It's doing a thing. But, it's also not doing a thing. And I feel like I have spent an hour here accomplishing nothing. Is it also just possible? Here's one. No, I was going to say one last thought is, am I possibly sometimes getting like 2 clocks per V blank? But I don't know how that would happen. Let me look at my code really quick before I totally just get out of here. So we wait for V blank. If X was not 0, we just loop again. But if it was, we have counted all the way down. And we read from the controller port, which should toggle the clock, which it clearly is. And then, you know what, we might be... Sorry, I should bring the source up. You know what I think is happening? And still, I will probably cut this off in a minute. Because this episode is, it's annoying me. But that just means that the next one will be, you know, a redemption story. I think I'm dumb. Well, not... I think it's just kind of scattershot because what this loop does, like I said, it waits for... This is checking a bit in a register on the GPU, which goes higher, you know, it changes its value when we're in V blank. You know what's probably happening is we're clocking multiple times before V blank ends, because this code does not take very long. So we're probably clocking a bunch of times, and that's why we're getting a bajillion clocks. So here's what I'm going to do, y'all. Here's what I'm going to do. I am just going to... I mean, theoretically, I could wait for it to go back high, but I don't really want to do that, and I don't know why I need this here in the first place. So, to save my own frickin' bacon here, I'm just going to go back to the original frickin' idea of doing a big old wait loop, and let's load Y. Yeah, sure. Load Y. This might be too long, but I'm just going to load FF into Y, and then we'll just do the same kind of loop with Y. So DEY, which I think and hope is a command, decrement Y, and branch not equal what was it? This? I hope. Should just mean the previous colon. Yes, so if it's not 0, then we just branch here, but otherwise we finally fall on through. So now we have an internal count up to FF on load Y, which, I mean, this is going to be 256 multiplied by 60, which is going to be, this is a 2 megahertz machine, so that's going to be a while. So let's switch the X counter to, I don't know, what would that be, like 256 times 4 would be 1,000, so, I mean, you know, would be 1,000-ish. So let's do, let's just do 10, keep it on the safe side. So we'll go in here, we'll loop Y several times, well, 256 times, and then we will decrease X, and yeah. So instead of relying on the, whatchamacallit, the V blank, I'm just going to use a good old delay loop, because I bet this is what the issue is. And 187, yeah, nope, I can't remember the syntax for this. Is it this? Apparently it's that. Okay, let's just build it really quick. See if it works in the emulator, and then see if it works in the NES, and then go to bed. Just go to bed. I deserve it. Last couple times we made so much progress. Having an off day is not the biggest killer in the world. Kind of a bummer, but if my theory here is at least correct, then that will make me happy. Okay, I think it's working, but it's even slower than I thought it would be. So screw it. Let's just make. Oh, we're also always reloading it to 60 here, which would be not good. I don't know. Let's just make it 1. Just so that in case that count to 256 is, because I'm counting, it's we already have to multiply by a few because there are it's gonna loop there forever. Yeah, you need to load FF into Y before the branch thing. That would also do it. So yeah, I don't know, maybe let's switch this to 3 or something, because it's still, there are a few instructions in there, so it's not just going to be 1 cycle, so I'm already multiplying by like 3 or 4. So cycle counting and exact science that I am not partaking in right now. It's not even that hard, but okay. That's an improvement. Now we just need to zhuzh that X number. Let's go back up to 10, why not? I assume the emulator is being pretty timing accurate, hopefully. That's supposed to be one of FCUX's claims to fame. And I shut down the whole thing. Good job. That is still very fast. I did build it, right? Could also just be that it's not really that timing accurate, though that would be surprising because I feel like NES games would all be pretty timing based. Well, whatever, let's crank this way up. Let's set it to 50. Just because we should see some difference. Whoops. There we go. I guess, screw it, let's max it out. Apparently this thing is faster than I thought. And FF is a hexadecimal number, so you probably want to put a $ sign in front of it. Okay, that seems like something I can follow. Cool. Let's see if that makes any difference at all. Let's prep ourselves for it not making a difference. Let's burn it. Let's see what happens. Let's get out of here. Okay, back to XG Pro. Back to... I don't know how you put stuff in favorites. That would probably be pretty useful. That's annoying. So what was this? 29EE010 is my, yes, is my EEPROM. Load my EEPROM image. Doody doot, doody doot. I am losing my mind. This is what I get for doing a late stream. It is, my brain is ready for bed. Basic type in, right there, right in front of me. Load at offset 10,000. Okay. Let me make sure the check ID is unchecked. Let's go to program and power off the NES. Pull out the chip. Try not to break it again this time. Come on, baby. Be my friend. I know you're a horrible Frankenstein invention that I have pulled out of the ether that never wanted to exist in the first place. But it's too late for you. This is your lot. Okay, in the programmer we go. Program. I said program. You just have to be firm with it. Okay, back in the cartridge you go. I guess we can move right over to this screen. Let's make sure I don't put this in backwards this time too, like I did one of the times. That we're just gonna... I was about to say that we won't speak of, but I guess I just spoke of it. So, already screwed that up. Okay, back in the NES. This is your last chance. You'd best behave. Or I'm going to sleep on it. So there. Ready? Troy Dempsey says, the NES says, kill me, please. I feel bad for it. Yep, that was it. Yeah, I should have had these facing forward, sorry, but yeah, it's fast, but it's counting perfectly fine now. Reliably. I think. It's going a little fast for me to pay attention. Okay, maybe. Or maybe it's just doing the same weird counting faster. I can't tell. Is it ever 0, though? Oh, this is making me sad, because the longer I look at it, the more I don't think it's ever 0. Which we can confirm by backing this up, and yeah. We never see the 0 light show up. I just got excited because they were counting fast. Nope, still being weird. Oh well. I made a promise, and I'm sticking to it. I'll see you guys next time, where I have, on a day that I have more sleep. I'm gonna go straight to bed right now. And that's that. Let me tell you, it's been it's already hectic doing these streams and doing the side work and doing my day job. And also, I'm on baby duty this week because my wife is not done with her job until, well, tomorrow's her last day. Which, you know, more good for her than good for me, because I should suck it up and take care of a kid and be a good dad. But that's going to give me a little more breathing room. Anyway, I don't know what the hell's going on, but I'll see you guys later for real this time. I'm signing off. As always,